My name is Lea DUNST, and I'm an international project manager at the German Solar Association. We represent approximately 1,100 companies all along the entire value chain with all the solar technologies, so that is photovoltaic, solar thermal, but also concentrated solar power and storage. And now you might be surprised to see this German lady from a national association here on stage. But since we do operate quite internationally for a national association, I'm delighted to be here with you in Marrakesh and welcome you to this event's second session on the strategic role of renewables for the green industry. And today we'll be focusing on policy more. So looking at the subject from a German perspective, I can say there's quite a bit of pressure at the moment. So there's much policy development and incentives laid out to create the right environments for companies and industry to decarbonize, and I'm sure you'll be guessing it already. It goes with large efforts to ensure the availability of sufficient amounts of green hydrogen for where it will be needed. But exactly why is the topic both so necessary, but also often controversial? So one could argue around it for three axes. So one, of course, being climate protection. Decarbonizing the industry is, of course, always about climate protection because the industrial sector accounts for 37% of global energy consumption. And by the way, most of it not at all for electricity, but for industrial process heat. And all that accounts for about a quarter of total emissions. The second pillar being energy security. So Germany is an energy import nation, and those who know about last year's explosion of the Nord Stream 2 gas pipeline between Germany and Russia will understand that Germany has had to and will continue to have to care greatly about their energy security, and that of course also leads us to the subject of green hydrogen. Energy security is both essential and often political, something that I do think with different aspects, but still in the same logic, we still have very much in our bones with regards to supply chain during the COVID pandemic. The third aspect, of course, is cost. So industrial locations are defined by the level of energy costs, which need to be stable and low. However, prices are currently unpredictable, and that is true for often renewables, but even for fossil fuels. So definitely an aspect the green hydrogen sector is challenged by and navigating for ensuring a competitive industry for the future. With 75% of the industry still relying on fossil fuels, we certainly still have a significant journey ahead of us. Fortunately, many of the technical solutions are already there, and many, such as green hydrogen, are strongly underway to become commercially viable. With all this in mind, and without further delay, let's dive into today's session. We'll start with 4 very short presentations, followed by a question and answers session, where you, beloved audience, if we still have the time, will have the chance to ask questions as well. So keep your thoughts in mind. Our first speaker is Amin Berada, who is here representing Terabase Energy, a California-based solar company where he is tasked with global strategic business development and marketing activities. Amin has previously held leadership positions in utility-scale solar power company SunPower US, as well as project and business development at Nereva, focusing on Middle East and Africa. Welcome, Amin. The stage is yours.
Thank you, Lea. I appreciate the introduction. Good morning, everyone. My name is Amin Berada. I'm a co-founder of Terabase, and I lead our strategic business development and our marketing activities. I do have a presentation that I hope will get queued. Perfect. There we go. Making sure we go with that. Perfect. So a quick introduction on what Terabase does, and then we can dive into today's topic. So Terabase is a solar technology company, essentially a spin-out of utility-scale business of SunPower. We're based in California, USA. We are in about 150 employees, and are venture-backed. We've raised about $70 million to date. And our mission is to deploy a digital and automation platform to reduce the cost of solar and speed up the rate of installation of solar power plants. The goal is really to achieve a massive scale deployment of large-scale solar, particularly attached to green hydrogen projects, as we know that 50 to 70% of cost of the green hydrogen molecules come from the electricity, and therefore reducing the cost of electricity is a key contribution to the sector. So to do that, we've essentially deployed tools to modernize the way we engineer, construct, and deploy power plants in general. On the engineering front, we have some optimization software. Construction front, we now have drones, image processing, high tech to basically smooth out construction management. And then on the integration front, we've developed tools to integrate solar power plants in hybridization situations, whether it's storage or hydrogen. And so we've deployed that in some of the feasibility studies we've been doing, particularly in Morocco. Our claim to fame is this automation installation system, which has been attracting a lot of investors. We basically deploy this automation line to help speed up the way you would install trackers and modules together by essentially improving the speed of installation by a factor of 2, which has repercussions on improved cost, improved safety, improved LCOE, improved quality as well. And this is something we intend to deploy around green hydrogen hubs. One additional thing that we started doing as a solar company getting into the green hydrogen world is turn our consulting services to green hydrogen advisory. We were lucky enough to obtain from the US TDA a grant to do a feasibility study, which is essentially a pre-feed at the level that we did it, for green hydrogen, green ammonia projects. And this is just an example of the scope that we did. We covered technology, we covered economic analysis, financing, environmental, and we welcome discussions around this topic where now we have a strong skill set and also a deployment of some of our tools as well. Related to today's topic, some of the learnings that we've had in interacting with green hydrogen, green ammonia projects is basically seeing the need for alignment in policy. Alignment in energy policy, industry policy, and technology policy in what we would like to call the concept of these green hydrogen hubs. And we'll dive into that in more detail in our discussion, but I wanted to pose that as an introduction. Thank you, everybody.
Thank you, Amin, for your lively introduction. And next, I would like to ask Peter Gish on stage. He is the president of Ornex Green Hydrogen and co-CEO of Ortis Climate Mitigation. Their focus is on renewable energy projects in the US, Europe, and North Africa. Some of his prior experience include serving as chairman at Apparent Inc., which is also a California-based solar company, and co-founded First Wind. Let's please give a warm welcome to Peter, and please join us on stage.
Thank you, Lee. Welcome, everyone. I want to start by thanking the organizers of the conference. I think it's provided an excellent forum for discussing the topics that we've been exploring for the last 24 hours and will continue to explore. Very briefly, Ornex Green Hydrogen is a partnership between my company, Ortis Climate Mitigation, and Acciona Nordex Green Hydrogen. And we are focused on the entire ecosystem within Morocco, starting with renewables, then production of hydrogen, leading to the production of derivatives. And we have a great deal of experience across the entire development and financing chain. We're bringing that experience to bear on the projects we're pursuing in the context of the Off Maroc. So we started about 2 years ago and immediately put up wind measurement and solar measurement stations to better understand the resource. We hired a team of 7 professionals who are based in Rabat and a larger support staff numbering about 25 people. We met with key stakeholders in the process around learning more about the plan of Morocco for green hydrogen and the policy strategy that was being developed at the time. And we've also been, as part of our ongoing effort for corporate social responsibility, been working with local communities and other stakeholders to promote the advancement of our projects. So there are a lot of words, a lot of terms, a lot of concepts being thrown around, but all of them center around clean energy, renewables. And if you look at the energy context of today, wind and solar are, without any doubt, the cheapest forms of electricity production on the planet. They provide an opportunity also for industry decarbonization today, as well as what Lee presented so clearly, you know, the key three cornerstones of policy, and including security. So when we look at what's happening worldwide in the context of Morocco, it's interesting to compare what Morocco is doing and what's going on in Europe, in Asia, and in the United States. I started working in Morocco in 2008 on wind projects in the north and central and south regions of the country. And I have lived personally the evolution of, let's say, the policy changes, the directives from the government and the palace, and the ecosystem that's been developed in Morocco for renewables and green energy. And I can personally speak to the fact that the country has been remarkably consistent. After financing a project in 2016, I took a break and came back in 2022 and was very pleased to see the progress that had been made in this country. More on that as we continue our conference and panel session. Thank you.
Thank you, Peter, for this inciting introduction. And now let's welcome our third speaker, who is Alberto Giaconia. He is a researcher at Enea since 2004. Enea is the Italian Agency for New Technologies, and there he is the head of Laboratory for Hydrogen and New Energy Vectors. He is bringing expertise on prototypes that went from laboratory to pilot scale to this panel. So great to have you here, Alberto. Please take the stage.
Okay, thank you, Lea, and good morning, everybody. It is a great pleasure to be here in this important event. Very interesting to discuss. Yesterday we had a good discussions on the development of power to X technologies, different aspects, and here I will try to provide you our contribution and how research and development can help to face the challenges of this hydrogen and power to X technologies implementation in the industrial sectors. So if we can go to the first slide, I just very briefly, next slide, please. Okay, I can. Okay. So very briefly, just to introduce ourselves, Enea is a research institution, public. We work for the Italian government. We are based in Italy with 9 research centers covering all the aspects of the energy, including, of course, renewable energy and hydrogen development. Currently, in my lab, we have about 50 employees working on fully 100% on hydrogen and power to X technologies, including the different aspects of the development. This is just an example of the list of the topics that we are covering with the research and development. But research and development is not only working in the lab, making analysis, cooperating with other research centers and universities, but also we provide technical advice, technical and scientific advice for industries on the one hand and policymakers on the other hand. So this means that research and development can play an important role as a hub of expertise and a pool of experts working in a different potential technologies that are not mature enough but need to be implemented as soon as possible in order to tackle the different challenges. So we are working on a different, let's say, rings of the value chain, from green hydrogen production using more emerging technologies, for example, high temperature solid oxide electrolyzers, molten carbonate, and so on. So also the hydrogen conversion to synthetic fuels, of course, methane and liquid organic carriers, also green ammonia, not only the production of green ammonia as a commodity, but also the cracking of ammonia to produce hydrogen back, and also hydrogen storage, fuel cells application, the development of what we call the BOP, the balance of plant of fuel cell systems, and other cross-cutting topics, including safety, hydrogen refueling stations, and pre-normative studies. So we are not working only in the lab, developing small prototypes, but also we are trying to expand also to the real environment with the development of what we call demo valley as a platform for training and for capacity building. So thank you very much. Happy to be here and ready for next discussion.
Thank you, Alberto. And now on to our last and fourth speaker of today's session. Philippe Marion is representing the EDF Group, where he has held several positions since 2012. Since 2021, he has joined EDF's hydrogen subsidiary, where he is now project director for the decarbonization of a cement plant. I'm sure this experience will be very interesting for us to hear indeed, so please be welcomed, and the stage is yours.
Yes, good morning, bonjour, and salam alaikum to all of you. I just want to add one thing, that I'm currently hydrogen product line director for the EDF Worldwide. Just in a few words, I will present EDF. So I guess that some of you have heard about this company, so which is producing the electricity and generating the electricity in France. We are a state company. In let's say I will just summarize this. EDF is known as a nuclear company, but also we are producing green energy. We have a dedicated affiliate company which is producing renewable energies, so solar and wind. We are also we have some expertise in geothermy and in all of the renewable possibilities. The key figures, let's say, from EDF today is to achieve the zero carbon objective by 2030. And there is an application that you can unload on your mobile, which provides you with the number of grams of CO2 that we are emitting per kilowatt hour, all the countries. It's named Electricity Maps. So I've checked just before coming on the podium. Today, at the current time, EDF is emitting 16 grams of CO2 per kilowatt, and 99% of the energy is considered as low carbon, and 1/3 is coming from the renewable section. Now, Now let's talk about the current situation worldwide. So we have these two maps on my left side. So I guess yes, it's yours as well. We can see the country that are producing green energy. So we can see that a lot of countries are already producing some green energies. But if we compare this to the percentage that the green energy represents in this country, we can see that there is clearly an unbalanced situation where you have some countries that are able to produce more green energy than they need, and that definitely you have some countries that are consuming that needs to get some green energy from others. So today we are here because we think that the schemes to balance this situation is to in some countries to produce more green energy and to use it, but in other countries to produce energy and to store it and transfer it to others that are willing to consume this energy. This is how we came to this solution to use electrolyzers to produce hydrogen and then to convert the hydrogen in ammonia, methanol, whatsoever, but ammonia mainly as a vector to transfer the energy. So where are we here? What are the technical and economic challenges that we are facing today to produce and store this energy? If we have a look to where we are today, we are in a nascent business and in non-mature market, so I need to speed up. So I guess that you know the issue with the hydrogen production. It's the maturity of the technology, supply chain, and also the regulation. But we need to do it because we know that because of the climate change, we need to reduce this. So from EDF, we have started to learn about hydrogen in 2000. So we are cooperating with a German institute to conduct R&D works. And in 2019, we have opened one affiliate company named Dynamics, who is taking care of all the hydrogen project. I will come back later on that. And we have also set up a platform to test the electrolyzers and to work with the suppliers because we think that this is an issue to get the right equipment with the best efficiency and the lower cost. So our target is definitely to commission large-scale projects. We are currently pre-developing some projects in Chile, US, Oman, Egypt, and hopefully in Morocco very soon. I think that this is the last slide of my presentation, just to provide you with an overview of the facilities we have to test the electrolyzers in our French institute close to Paris that everybody can visit. It's open to the public. Thank you very much.
Thank you. Thank you, Philippe, for your introduction as well, and great to have you all here. Let's dive into the subject a little further, and starting with you, Amin. What do you think are the current challenges in policy and economic framework for green hydrogen, and how do you think countries can address these challenges?
Thank you for the question, Lea. In spending the 12 past months studying deeply green hydrogen, green ammonia projects in Morocco, we've come up against a number of challenges that I want to list out and be able to hopefully provide suggestions on how to address. Number one is high production costs. Obviously, this is not a surprise to anybody. High production costs coming from the industry being nascent, as was just described, also coming from generally a stack up of expensive capex due to immaturity and other things. So this is the first thing to be able to address, and some elements on that include incentives, which is something that we're seeing in the US with the IRA, and being able to also provide kind of tax types of rebates as well. The other element to that is innovation. This is something that we're doing. Other companies, as part of some of our investor ecosystems, are also innovating to reduce cost. And let's not underestimate how innovation can drive cost, which has an example that we've seen in the solar industry, in the storage industry, and for sure will be applicable to the hydrogen industry. And then lastly, economies of scale. Big projects, big volumes, was seen from the Chinese industry around solar and batteries. Large scale is a strong cost reduction driver. And so we believe that's also part of the recipe. Luckily, a lot of these green hydrogen, green ammonia projects are actually really big in size. They start at the gigawatt level, so this is an opportunity for cost reduction. Other challenges, and I'm looking up my notes here, basically insufficient infrastructure. We are seeing that a lot of the projects depend on export infrastructure, at least in Morocco. There's obviously a large off-taker in Morocco that consumes its own ammonia or hydrogen, but most projects that are slated for producing green hydrogen, green ammonia in Morocco are destined for export. export infrastructure is not yet ready. It would not be ready for a while, so that's becoming a bottleneck, and it's actually, in our view, forcing projects to be located next to export infrastructure, which may not be, at the time, the best renewable energy resource. Policy uncertainty is another big challenge. We're seeing basically a bit of a complex composition between European offtake regulations, productions, and a bit of a mismatch between what would be the European requirements for import and then the exporting countries. So some kind of harmonization, and I would say an opportunity for simplification is definitely needed. And finally, limited demand. It's been pretty obvious in this conference, but chicken and egg story. We do projects when there is offtake. Offtake requires projects. And so how do you get more demand? We think part of that, addressing that, is to give strong market signals, such as mandates. One recent example has been fuels for sustainable aviation fuels, where there's been European mandates requiring a certain quantity of green molecules. That's given such a strong signal to the industry that a lot of projects that are making hydrogen derivatives have started to think about making that product instead. So a clear signal, mandates, is also part of addressing that. Thank you.
Thank you, Amin. And it's great that you have brought up the point of infrastructure, because let's go over to Peter on that aspect. How do you think, how important is a new infrastructure for the development of green industries?
Let me answer that question by looking at the world we live in today. How many of you know in the audience when the commercial scale, first commercial scale oil refinery went into production? And I'll give you the answer. It was 165 years ago. Last year alone, the oil and gas industry received $7 trillion in subsidies and support. The president and CEO of Occidental Petroleum at Climate Week two weeks ago in New York City stated that the oil industry should burn all of the oil and gas left in the Earth's mantle before they switch to clean fuels. So policy really has to take a look at where we are today and recognize that the infrastructure, the financing, the public support mechanisms, the markets that we need to promote green hydrogen are far from where they need to be. And the reality is that the oil and gas industry has no desire to see green hydrogen succeed anytime soon. So policymakers, governments, others involved in this debate need to understand that, as I think the Minister for Energy Transition stated yesterday at the opening remarks, the time for PowerPoints and non-binding MOUs is over, and we need a very clear and concise and comprehensive approach to policy and regulation that allows the infrastructure of this market to evolve correctly.
Thank you, Peter. And maybe now turning more towards the offtake side. So Alberto, currently, what will be the role of green hydrogen in the decarbonization of industrial sectors? And given your expertise in these areas, what development status do you expect South Europe and the Mediterranean area to have?
Okay, thank you, Lea, for the question. Well, I can connect to the previous answer from Peter, because first, as we are discussing about the role of green hydrogen in the decarbonization of industries, we can analyze the actual situation. Today, hydrogen, possibly we do not see so much hydrogen in our everyday life, but in the specific industrial environment, we know very well that hydrogen is very much used Today, we are producing in the world, I think, about more than 100 million tons of hydrogen. For example, in Italy, it is about 1 million tons of hydrogen produced and consumed every year. And this is done in chemical industries, specifically in refineries first, but also ammonia, methanol, so in the specific environment. So hydrogen technologies are already developed, most of them inside the industrial environment. The problem is that this hydrogen is black, brown, or gray. So the problem is that we have to convert this gray hydrogen into green hydrogen. And so we need infrastructures to do that. And infrastructures means renewables and electrolyzers and all that is needed to make, at least to decarbonize the actual hydrogen production. And this is not negligible. If we make a few calculations, we understand that this is 1–2% of total CO2 emissions. This is not negligible, but this can be a very important starting point to establish infrastructures. And infrastructures, what does infrastructure mean? Meaning that we have to develop an important, a significant capacity, additional capacity of renewable sources and install gigawatt or terawatt in scale electrolyzers. This is important, and we are doing something. For example, in Italy, we are developing a number of hydrogen valleys. Hydrogen valleys are small, localized in ecosystems where hydrogen is produced, green hydrogen is produced and used, possibly in brownfield areas. But the importance is that, okay, we start with the installation and also to develop the skills and the capacity to operate this kind of plants. But this will not be enough. This is very much localized. This is not global. We have, in the end, this will be only 7,000 tons of hydrogen produced per year. This will not be enough. But according to the plans, in 2030, we'll have to produce 250,000 tons of hydrogen. This is significant. And this requires gigawatt electrolyzers. And that will not be enough to use internal resources in the countries, but it is important to activate some international trading of green hydrogen. And here comes the big infrastructures like the corridors that are going to connect Africa, for example, North Africa with Europe. And I would not like to call them only corridors, but hydrogen highways. This will speed up the process and the infrastructure for green hydrogen trading. Thank you.
I do hear one of the buzzwords connecting all your responses so far, infrastructure. Yeah, indeed, really is key. So let's move from this implementation perspective maybe more onto the policy side with you, Philippe. And the next question. So given that in your presentation you showed many countries which still have rather low installation rates with regards to renewables, and how do you think, what would be smart strategies for them if they still want to get in the hydrogen game?
So for me, the main, let's say, driver will be collaboration. There is no one, and so no state, no company, of course, able to deal from the renewable generation up to, let's say, green ammonia production or transportation. So really we need to collaborate between, with our politics, because first we need to define the rules, what are the conditions to make sure that the final product will be considered as green and will be certified as such, because this has a value, of course. We need also to work with off-takers, as we said. Some of them will use the ammonia directly for co-firing, for instance. Some others will crack the ammonia back to hydrogen. So really there are a lot of schemes that can be, let's say, that can appear. So the issue is really to collaborate and define some together the the frame of this hydrogen business that is today very nascent and that is lacking of maturity, definitely.
All right, thank you, Philippe. And then now going back to you, Amin, and staying in this, let's say, government area of things. So what do you think, how can governments effectively align their economic, industrial, and technology policies to ensure the sustainable growth of green industries while fostering innovation and maintaining global economic competitiveness? Please try to stick to around 2 minutes.
Okay, thanks for the warning. I want to start by actually agreeing very much with Philippe on the need for collaboration. I think what the industry of green hydrogen is teaching us, that there is a new level of collaboration required to be able to advance and solve the problems. There's complex systems that need to be solved. Collaboration between the world of power with the world of molecules, the world of policy with the world of economy. And I think aligning these policies, policy of industrial policy, economic policy, technology policy, needs to be actively done in order to be able to advance this industry. And as was mentioned, doing this through hydrogen valleys, industrial clusters, or green hydrogen hubs, I think is a good place to start, where you can have an ecosystem where you can experiment with new R&D innovation that can potentially reduce cost and drive new advancements, industrial policy that can have mandated targets, or also complementary synergetic behavior where the waste of one industry can be the input into the other industry. This is something we're seeing, for example, on the ammonia projects, where there's a lot of heat being generated, and there are industries that could be taking this heat and being more efficient with it. And so this synergy can be studied and experimented with in these hub environments. And then lastly, we could have targeted policies, economic policies, around incentives for these specific hubs, industrial zones, free trade type agreements, free zones, and tax breaks and all that. So aligning all this, which means that collaboration needs to happen across different ministries, across different industries, I think is key to success in this area.
Thank you, Amin. And yes, definitely, I always find that very interesting to see how much heat it is actually, and that can be a resource harvested also and often already available in processes. Thank you. So going back to you, Peter, and maybe a little bit of a different perspective. So what role could development finance institutions play in shaping economic policy that facilitates the transition of carbon-intensive industries to fossil fuels to renewables?
The development finance institutions, in my opinion, would play a critical role in the transition to a green hydrogen economy for two very simple reasons. Number one, they're not necessarily motivated 100% by profit. There are certain social, environmental standards that they follow for all financings. And so in the analysis of projects that they decide to provide senior debt or equity to, they can adopt the existing performance standards to include what I've termed fossil fuel transition metrics. So in essence, the large public finance institutions worldwide can look at the entire chain of project development. So it would include renewables, but it would include the electrolysis, it would include the molecule production, Haber-Bosch and Fischer-Tropsch, and imply certain consistent understandable requirements that would lead to a positive decision from the investment committee to fund a certain project. So they really are extremely important in my mind for facilitating the transition because they control immense amounts of capital that the industry needs right now to have a bridge to compete with more conventional sources of energy, and also to build the infrastructure, because it will signal the market that this is now a top policy priority, and will also encourage investors and others in the entire ecosystem to make the policy and regulatory requirements that allow green hydrogen to become a reality.
Thank you, Peter. And now turning again to Alberto, and it's great to have a researcher on board to complement this policy perspective. So let's try to get a little bit from that perspective. So for the establishment of now this time renewable fuels from power to gas technologies, what are the research and development challenges, but at the same time, economic incentives necessary to make them sustainable?
Yeah, sure. Research and development is something that is more looking at solutions and innovations. First, I think to reduce the cost. Reduce the cost means that we have to comply with the reducing of the cost of hydrogen production, so looking for new materials, components, higher efficiency electrolyzers. Steam system integration is also very important. And but I'm not only talking about hydrogen production, also the infrastructure for the CO2, for the carbon dioxide that is required to produce, for example, e-methane, synthetic methane from methanation, or even higher hydrocarbons, other carbons as a fuel. So reducing the cost is first, and doing research aiming at reducing, for example, the impact of critical raw materials is very important. Second, the integration with the renewables. This is really important. We are developing a new kind of chemical engineering, more focused on the dynamics of a system, of a chemical plant that is requiring heat and power, and this heat and power might not be provided at constant rate as usual. So we have a new dynamics in the process, and we have to optimize the system still to reduce the cost, but also to improve the operation of the plants. Regarding the financial supports, yeah, of course, we need to face this transition period, and the way I think will be to provide the financial coverage of that gap that we have between, for example, the gray hydrogen and the green hydrogen production. If gray hydrogen production cost is $1.5 or $2 per kilogram, and green hydrogen is $6, for example, then we have to supply all the necessary financial supports to balance this gap. And in the second time, also we can consider the very important impact that the cost of power in the final cost of the hydrogen from electrolysis. So, for example, placing a cap to the maximum cost of a power that we can accept, just to keep the green hydrogen cost as low enough to make the renewable fuel or the X final product more convenient and at least competitive with the more conventional or traditional routes. Thank you.
Thank you, Alberto. And Philippe, so you have, in comparison to the research perspective, the perspective from implementation from said cement plant that we have talked about earlier and other EDF projects. So from these projects that are already addressing industry needs today, so such as the mentioned cement plant, but also production of sustainable aviation fuels, are there any lessons you can share with us on how to do this effectively?
So I will say that the main target at the beginning was to decarbonize the industry. We have two main objectives at that time. So we want to decarbonize some industrial sectors, as well as to learn about the electrolyzers. Because the technology will drive the project. Okay, we can think about starting reducing the cost, but the cost of what technology? So we have developed 3 projects in France, one which is dealing with ammonia, so green ammonia. So we are using directly the green hydrogen to produce ammonia. Another one to produce e-methanol, so using green H2 with CO2. And the third one to produce sustainable aviation fuel, so let's say SAF. So we are capturing the CO2 from the cement plant, because you know that in a cement factory, the CO2 is a process, let's say it's coming from the process reaction, so you cannot avoid it. So it's called fatal CO2, but I know that people doesn't like this word. So the lesson that we have learned from this project is that today, for this small project, definitely we need some subsidy, and we need to let's say, to adapt ourselves to the rules, but the rules need also to adapt themselves as what we are doing. So we are collaborating with the authorities to define the condition, let's say, to certify our final product as well.
Thank you, Philippe. And so I think we're actually already coming to an end, which is very unfortunate because it's a very interesting things that you have brought up, and I wish we had more time to dive even deeper into them. And I think there is an interesting conversation to have in between you probably afterwards, but also for audience with them. We are already a little over time. We started a little bit later, but I think we are still in our accorded time frame. So unfortunately, that's all we have time for today. And thank you for listening and attending today. Thank you for your insights. And have a great rest of the conference.